Hello, everybody. I'm glad that you enjoyed my presentation. And it's always hard to see myself pre-recorded and then talking and then why did he say that? Why? Anyway, so I'm still going to talk about MySQL ecosystem in 2018. What's new and exciting? World's most popular open source database. Now there are several databases which in one way or another try to claim that they are world's most something, and MySQL claims it's world's most popular, which is compared to PostgreSQL, which is most advanced, and SQL-like, which is most widely deployed. Very important not to confuse. All right. So my name is Laurynas, as already mentioned. And I work as a C++ developer and tech lead for our MySQL database server in Percona since 2011. Before Percona, I tried to do database PhD, but that didn't went quite according to the plan. Nevertheless, I learned quite a few things there as well, which is good. A word about Percona. So we try to be open source database experts, and we try to be database agnostic as we expand our knowledge. So we do MySQL, we do Mongo, we do Postgres, we do a bunch of surrounding technologies, and we try not to shove a bad match of a technology down a customer's throat just because we happen to selling it. We believe in best tool for job. Hence, we are in a good position to evaluate technologies. Enough about me. Let's talk about MySQL. It's an old database. I think everyone can agree about that. Postgres is older, but that doesn't make MySQL very young. So obviously MySQL, as of today, is past peak public hype. The hype has moved elsewhere. We had MySQL, we had NoSQL, we had new SQL, we had everything. But that does not mean that MySQL is not used these days. In fact, it runs some of the world's largest online transaction processing databases in social networks, in services, in many different areas. And another feature of MySQL world in the past decades is that it's not suffering from the lack of politics. There have been acquisitions, there have been public blames of some involved parties, doomsday predictions, and so on and so forth. Regardless, besides all those politics, it is still a healthy project where code flows all directions, where people manage to cooperate even while competing. And as a result, the development is gaining momentum, and this could be a strong claim, but I'll try to support it later. So first of all, let's try to see how exactly is MySQL popular in 2018. So there is this dbengines.com ranking, who have been tracking the databases, open source, closed source, all flavors by their own methodology of popularity. And there, MySQL has been in number 2 place for what I believe years, just past the Oracle relational database. Their methodology is not perfect. They mostly measure what is possible to measure, which is mentions on the web, numbers of job openings, numbers of social network mentions. And in the past, if you go down below top 30 or so, you could find some funny things like completely that project taking a relatively high place just because people still manage to not to delete from the internet what they wrote about it before. Still, this is the best what we have today, and by this measure, MySQL is going strong in 2018. What else? On Stack Overflow, MySQL is the most discussed database, which of course a devil's advocate could play and say that, hey, nobody understands how to use it, and you have to go to Stack Overflow every time. But this is not true, I would like to believe, and so it confirms that well, it is being used in 2018. So what happened? What happened in this year? Let's start with the main product, with the Oracle MySQL itself. There we have the 8.0 release. It's a big release after some 3 years of development. It follows the previous 5.7 release, which was released in 2015, which was also a great release, and from my point of view, even 5.7 features, the 3-year-old features, have not seen the level of uptake they would deserve. The native document store, the JSON type in the relational database, the X plugin, the asynchronous connection feature, the new MySQL shell client, which replaces the MySQL client as everybody knows it. Huge replication improvements in parallel replication, and so on. So users have not quite caught up with 5.7, and now we have 8.0. And 8.0 is even better. It has new data dictionary. I love 8.0 for this reason alone, but as a C++ developer, it's easier to work with it. It has features for operations. It has features for application developers, and I did not try to list all of them here. I included a link for if you want to. So let's just go and look what those are, selected ones. The new data dictionary. Well, everyone who worked with MySQL in more than 5 minutes knows what a form file is, which stores the table definition. So they are gone. And gone are problems of their corruption, of their the syncing from the corresponding InnoDB data file. What they have been replaced with is the system InnoDB tables, which make a new transactional data dictionary. InnoDB is, of course, a fully ACID compliant storage engine, and using it for data dictionary makes that ACID available through the data dictionary very beneficially, such as crash safe and atomic DDL statements. In the previous versions, those statements had varying degrees of crash safety, but usually not satisfactory degree. When a statement has to do several things, when one of them fails and one of them is on a file system, or two of them are on a file system, it can fail in the middle, and then it's up to you to come in and mop up what's there. Furthermore, because we don't have any metadata files, we have fewer files in the file system, and that means we have to deal less with file system bottlenecks. If you have 1 billion form files, those bottlenecks show up rather quickly. I'll have an example in the next slide. And on a related note, if you want to do that, you can create now 1 billion tables. The previous versions, they top out at I'm not sure, somewhere above 100,000. And with 8.0, my colleagues, they did experiments, and he managed to do 1 million, 3 million, 10 million, and finally 1 billion tables. That took 2 weeks of great table execution. Another good consequence of not being dependent on the file system, but on having the data dictionary is now that information schema queries where you want to know what tables you have and the like, they'll become really fast. I'll have some example in the next slide. But there is a single, I wouldn't say a drawback, but a challenge nevertheless, is that recovery and troubleshooting is still new at this point with 8.0 and unexplored. And we don't have enough case studies from the field how to do things there, because the old tricks of going to shell and doing CD and ls and then looking at the form files, they will not help you. And if you have some sort of corruption, well, it's slightly hard to uncorrupt DB tables. There are tools provided though. You can in an offline way on shutdown server to get the table definitions in JSON, I believe, in serialized dictionary information form. And so we'll see what future holds there. About those fast information schema queries. So I took an example from my MySQL blog itself, where they had really many tables and executed a set of queries on 5.7 and 8.0. The 5.7, in the worst case, 5.7 takes more than 40 hours, and 8.0 is essentially instant. It's no point in comparing. You can only use adjectives like infinite and instant. Even in a case when you have 1 billion tables, the information schema query still takes significant time, but it's at least possible. This, of course, makes sense because in the past those queries were usually essentially scripted directory tree walking and file opening, and now you have the full power of DB and the query optimizer and the information schema queries. They become use. All right. What other new fun features we have? We have new keywords, new SQL keywords for hot row handling. No wait and skip locked. The demand for them was rather high. There were existing users because now we have total maybe 4 implementations of this feature. So it started with in 2 big vendor patches, Alibaba patch and Facebook patch. These were independent as far as I know. And MariaDB, if I'm correct, merged the Alibaba patch, and MySQL implemented it from scratch. So what do we have? When you want to select a row for further update, but you don't want to wait if it's locked, you can specify no wait. Then you immediately get an error to the app that this row is locked. Of course, you can work around it by setting in the session the row lock timeouts, but there are even some cases where it would not be sufficient. Then the second extension is the skip locked. When you want to get some rows, you don't care which ones, from a range. So you specify skip locked and you get some non-deterministic subset, whatever happened to be unlocked. The use cases are, well, Cinema seat picker right in front of me. One of the use cases is here for holding a reserved seat while booking is being completed. Of course, it was possible to do that before without this feature, but I would say now it becomes more straightforward and easier in the app. Another good feature, which is new in 8.0, is now that you have instant add column. Because you have to provide the default or set it null, so you don't have to rewrite all table existing rows. This is enabled by the new data dictionary, by the way, because you still have to lock the table metadata definition somewhere, and with the new data dictionary, it becomes much easier. This is not the only instant operation. You can change index options. You can rename unused table. You can set drop default value for a column. You can add drop virtual columns. This example is good because it's the heaviest operation, which naively would ask for a table rewrite. Whereas changing the table comment, yeah, it's obvious that it's instant. Then let's talk a bit about JSON. So 5.7 introduced MySQL document store, where it even had the whole new protocol, not a legacy MySQL protocol, and new clients and everything. So it appeared to be a regular document store database and a SQL database in one. However, of course, the first version release features need refining, and refining happens in 8.0 and is ongoing. So one challenge with JSON in 5.7 was that updates were expensive. They were mapped to the pairs of delete and insert, even though you wanted to update just a little bit. Now in 8.0, JSON replace, who of course is not before and after for the whole document. It has a path and what to replace with what, is implemented much more straightforwardly down to storage level. That delta is applied in place, and no longer it's a delete plus insert. The next challenge here with JSON in 5.7 was replication in row format. I forgot to mention that my talk kind of assumes some familiarity with MySQL, but well, I guess it's too late by this point. So the issue in 5.7 was if you used row as your replication binary log format, all the new row images were getting locked. So again, you have an issue that you, for 10-byte update of 1K doc, you write 2K to the binary log, and of course, then you ship over the network 2K, and so on. So now there is a new replication option which makes this binary logging more efficient, doing the right thing of logging the delta. It is not the default though, because you might want to replicate to an older version server which would not understand this. Another funny feature is JSON table. You take a document and here it is converted to a table. Of course, you have to provide some information how exactly you want the conversion to look like. How to handle type conversion errors, there are options for handling arrays, nested documents, and so on. But once you have it, then you can use full power of SQL or for your JSON. You can do group by aggregation. You can do what else you want. The gap the other way from relational to JSON was breached in 5.7 already. I think the function is called JSON array ag, and so you can already go from the table to document. Now we can go both ways. Then SQL Query Optimizer has received significant new development. This feature common table expressions present in most other SQL databases and in MariaDB since one version before. So what are those common table expressions? So first of all, they come in two kinds, non-recursive and recursive. So non-recursive ones are similar to queries with derived tables, except that they have names, and so you can reference to them more than once. But recursive ones are more interesting. So what you have here is that you start with a single row, and you have a query, query, which takes that single row and produces something else, or another result set. And then you take that result set and apply that query again. And you do that until you stop producing new rows, or until you exhaust memory or hit one of the limiting variables for this case. So this is the most trivial, the most easy example, just to show exactly the easiest, the simplest case how it works. You can do a bit more complicated things, and for the user who is not interested in toy examples, these are used for tree walking, for graph walking, where you build some path, like organization hierarchy path as you repeat the rows. Okay, then we have window functions. So these are powerful for analytics. MySQL is not exactly an analytical database, but you can do things. And for example, you can do a moving average query like this. So you can imagine this as you take the table, order it by date, and you have and you define a sliding window which starts at one row before the current row and stops at one row after the current row, and you take an average of that. This is just one trivial example. The wall feature is has many more features, so to speak. Okay, then operations should like this one, set persist. Historically, making MySQL configuration changes, unless of course you have good automation, requires two steps for any dynamic variable. Is that you can enable it on the running server, and then you have to make sure that it will take effect on the next restart too. And for that, you have to edit the configuration file, and you have to hope that you edited the right configuration file and that you didn't make a typo. And the only way to verify this is to restart it. So manageable, but probably the set persist one is a better way. So now you can do everything from the MySQL client. You don't need shell. You invoke set persist and everything is done. You can even set read-only variables with the syntax shown, and this way it will take effect on the next restart, which, if you want to, you can also do with the new SQL command restart. It was not present in the earlier versions. All right, so these were selected MySQL features. So there were many. I selected a few. Maybe you would have selected a different set. But let's move on to MariaDB. So for those of you who are not familiar with MariaDB, it started around Oracle acquisition of Sun, which had acquired MySQL 1 year before. And what happened is that original MySQL developers, some of them made a lot of noise that Oracle is going to kill MySQL. This phrase has been repeated so many times that I feel bad saying it once more loudly. But the thing is that almost 10 years later, we can say with confidence that this has not happened. If they want to kill MySQL, they really have some sort of very slow plan to do that. Nevertheless, MariaDB project, who started to preserve MySQL, so to speak, they made ourselves different too. For one thing, they are more open to community development. For another thing, they always were on the lookout on on features that would make them better than MySQL, and that MySQL would not necessarily implement to catch up. However, on the other hand, they are also not implementing all the MySQL features, and as such, they are diverging more and more with each version. So they are no longer comparable to some parallel MySQL version. It is no longer the case that it's very easy to replicate from one to another. You have to be very careful. And another political thing, what happened is that MariaDB won the distribution, Linux distribution war. So in many distributions, if you ask for MySQL, you get MariaDB, which was enabled by some Oracle development practices, not showing security bugs, not disclosing them. So distributions liked MariaDB a bit more. So what happened in 2018? MariaDB 10.3 is generally available. And the flagship features there are system versioned tables and Oracle relational database PLSQL compatibility. They also added the instant add column, same as MySQL, but different implementation. And they also took sequences from SQL standard, which I believe was also done under the umbrella of PLSQL compatibility project. And of course, lots more. They have many more smaller features, which is enabled by the development being more public. It's easier to get a patch in. So if you have an itch to scratch, it's easier to do with MariaDB. So let's see, what are the system version tables? So simply said that you add a clause to create table or alter table to add it, and then all your rows start logging history of what happened to them in relation to time. So if you just insert one row, one primary key value with some other column values, and then you update it several times, and then you do a query to show all versions of the row, basically, you get the result. So here, column A is primary key, and you see that you selected from a table, and you have the same primary key value multiple times. Well, that's because these rows were alive at different times, which are here shown as well. Also, you can see that this is implemented through hidden columns, row start and row end. So select star does not include them. Not that you should use select star in production, of course. There are other options. You can see how the table looked at a specific moment in time in the past, and you even can do that in transactional consistent and inconsistent way. You have both options possible. If you use InnoDB, then you can specify transaction ID, and then at that moment of time, you will not see the rows which were written but not yet committed. Space management, of course, is a problem because history grows. So you can partition tables by history, and then you can drop those older history partitions as you like, or you can just remove the historic data altogether as you wish. PLSQL compatibility. So they expanded the SQL mode Oracle setting, and they worked in the parser to make it compatible with PLSQL. Change stored procedure, stored function, cursors, loops, variables. Some functions started having different semantics. My favorite is that empty string and null became identical, just like in Oracle. And they also implemented package support in Oracle style. The idea is, of course, to make migrations easier or possible. Well, we are still missing out the use cases of those migrations actually happening, because probably migrating from Oracle takes more than rewriting PLSQL. So remains to be seen. That's also one feature which it's not as probably a stretch to say that Oracle MySQL does not have any immediate plans. What else we have? We have sequences. So we have a number sequence generator with a name. You create a sequence, you specify where it starts, how it increments, and you can get its new values atomically. So if you use auto increment, this is very similar, just more powerful. Okay, then what I'm working on. Percona server for MySQL. This is the third major kind of MySQL-like database. So we are not a fork, we are a patch. We try to track MySQL development closely. We do not want to diverge like MariaDB. And we differentiate by providing enterprise features for free. So MySQL has Enterprise Edition, which has thread pool, which has PAM authentication. We provide those features as well. And some others, I'll talk more. Then, coming from Percona, who started as database consultants, Percona server has a serious instrumentation patch, so that our consultants and support can work in the field easier. We have performance and scalability fixes. That's also something which started maybe 10 years ago before my time, at the time when InnoDB did not scale to 4 core CPUs. There was a huge need for performance patches then. So Percona started doing that. Then InnoDB fixed those problems, but we still try to maintain the lead in performance. Then we have some selected new features, which is not the focus of today's presentation. If you want to learn more, there's a link. So let's see what happened in Percona server in 2018. So past the MySQL-like generally available release, we've been hard at work to make our own generally available release, and I hope we are some short 2 or 3 weeks away from that. We are currently having our C release. And then we have data at rest encryption, and then we have MyRocks. Let's look at those each in turn. Data at rest encryption. Some users for all the SQL databases started asking for having the option that whenever data touches disk, it is encrypted. Okay. So everyone started working in that direction, and MySQL 5.7 introduced encryption of regular InnoDB tables if you use file per table, and also introduced key management framework with some options. One option is to have a key stored in plaintext file on a file system, and if you go with Enterprise Edition, then you have better options. Then MySQL-like encrypted InnoDB redo and undo logs. And then, well, not in time then, but in parallel, MariaDB, they received a contributed patch in Google maybe in 2014, which tried to encrypt everything. So that included bin log encryption, where it was temporary files of server operation, and also such features as key rotation, so that a thread periodically walks and rewrites all the data with all new keys. And you could store the keys in Amazon Key Management Service. So what we did is that we tried to take the best of both, which is a bit peculiar because MariaDB implementation is absolutely incompatible with MySQL one, and we don't want to sacrifice MySQL compatibility. So we took the MariaDB features and rewrote them one by one to fit MySQL encryption framework. We also provided a HashiCorp Vault plugin for key management. And as the end result, now in 2018, with Percona server, you can reasonably run everything is encrypted server. Reasonably means that you should not be using MyISAM tables and the like, which we did not bother to encrypt. Another big development for us is that we started shipping MyRocks as a GA, as a general available engine. What is MyRocks? So Facebook was a long-time user of MySQL with InnoDB. They hit some InnoDB limitations in that specifically they were not happy that InnoDB tables take too much space in their view. They tried to resolve that by using the existing InnoDB compression. However, even though they were using that in production for some time, the savings were not satisfactory. So what happens is that they took RocksDB, which is another software project, and wrote a storage engine on the top. Now, what is RocksDB? RocksDB is a key-value store library. Well, plenty of them, which is fork of Google LevelDB. What it makes it different is that it uses the so-called log-structured merge tree for data storage instead of classic B tree, which most of the databases, including InnoDB, use. The defining features of LSM trees for a user is that it's optimized for writes and optimized for disk space, while reads should not be penalized too much. They will be penalized, but sometimes the penalty is avoided altogether, and sometimes it's manageable. So as of now, the MyRocks is running in Facebook internally in production on several their databases, and however, they also wanted to see its uptake in general public. It's hard running open source project when you are the sole user, and Facebook needs a special, a bit diverging from the general user's needs. So this is where we and MariaDB stepped in. We took the storage engine, we integrated, and in integrating, we of course fixed bugs and implemented some missing features and wrote documentation and so on, and started providing support as well, so that MyRocks is a generally usable storage engine. So by now you might want to have a question: why there are so many forks? Well, that's because it's hard to contribute code to MySQL. I have done that, I know. And all the big web properties, they maintain their own patches, which are not necessarily even contributable to the respective upstreams. So we have plenty of branches, but it's all good. It's a sign of a healthy ecosystem. We also have dead branches, such as Drizzle and WebScale SQL. So non-working ideas get killed, and working ideas get pursued. Okay, I'm apparently running out of time. Okay, so clusters. In 2018, you have basically one option if you want to run a cluster. Well, built-in replication is not a cluster. So you use a Galera-based cluster, which is either Percona XtraDB cluster or MariaDB, which is a known, stable, and performant solution by now. But what happens is that Oracle works on Group Replication, which is their answer for clusters. They released the first version 5.7, but the first generally available version. But we did not agree that it's generally available. It's still, as of today, if you want to add a new node to their cluster, it's a manual process. You cannot just point empty nodes to existing cluster and say this is where you take your data from. You have to preload the data first. Still, the dynamics are clear. If Oracle Group Replication is not GA, it will become GA soon. What else we have with around MySQL? Well, we have proxies. And in 2018, the best option is probably the proxy SQL. Actively developed, 2.0 coming soon with exciting features, just like GTAD consistent reads. You have other options, MySQL router, which is tailored for group replication more than asynchronous replication, and MariaDB max scale, which is very powerful. Unfortunately, it has a poor license. Well, it's a matter of, some might say it's a good license, but anyway, so this is business source license, which is essentially closed source for the first few years. Okay. Oracle is hard at work to release the so-called InnoDB cluster, which encompasses their vision of how MySQL should look like in the future. So they see that MySQL will be run with group replication, proxied by MySQL router, and you'll use MySQL shell to connect it to it. MySQL shell is a replacement of the legacy shell client. Okay. Backups, nothing new. Percona extra backup, unless you need to back up MariaDB when you have to do Maria backup. And I think I'll just stop there. Thank you.